Welcome everyone. The question that is shown on the screen, it came in CBSE 2026 physics question paper. The radiation of wavelength 200 nanometer is incident on a photosensitive surface, okay, of work function 4.2 electron volts. It is from the Einstein's photoelectric equation. The kinetic energy of the fastest photoelectron emitted from this surface will be close to 4 options are given. So close to is important here. Close to means we have not to find it of the exact value, but which is very close to. So 3.5 electron volt, 3 electron volt, 2.5 electron volt and 2 electron volt. 4 options are given here. So what we have to do, we have to understand what we have learned before. That is, if a photon, okay, is incident on a photosensitive surface, it is having the energy h nu, then W naught amount of energy is used up in coming out the photoelectron outside the surface, and rest of the energy this electron have, okay, to with that the electron basically coming out, and we can say that is the maximum kinetic energy. And now if I write it down in the form, that is what Einstein have said, h nu, the energy of the photon, it is used up into form, that is W naught plus of E max. And here we have to find it of the Emax, that is the maximum kinetic energy of the photoelectron. So Emax equal to, we can say it is h nu, that is the energy of the photon minus that of the work function. Okay, here the radiation's wavelength is given, that is the lambda equal to 200 nanometer. That means 200 multiplied by 10 to the power minus 9 meter. So if you want to find it out what is the energy of the photon, if I say that is E equal to h nu, and nu equal to c by lambda, so it is hc divided by lambda. H is 6.626 into 10 to the power minus 34 multiplied by 3 into 10 to the power 8 divided by 200 into 10 to the power minus 9. Okay, so I can write it down it as 6.626, okay, divided by 3, sorry, divided by 2, okay, 3 comes here, so 3. Now calculating the powers, okay, so 10 to the power minus 34 plus of 8, 10 to the power minus 9 is a denominator, so it goes up, it becomes plus 9. Okay, after that 200, so 10 to the power 2 is there, so if it goes up, so it is in the numerator. So if I just divide it, it simply becomes 3.3 13. So if we multiply this is 39 9.939, okay, and it is 10 to the power minus 34 minus, so minus 36 plus 17, so obviously it is in joule, so this thing becomes 9.9, okay, 39 multiplied by 10 to the power minus 19 joule. So obviously if I want to convert this thing in the work function, that is 4.2 electron volt, so if I convert the joule into electron volt, so obviously it is 9.939 multiplied by 10 to the power minus 19 divided by 1.6 into 10 to the power minus 19. Okay, so 10 to the power minus 19 and 10 to the power minus 19 cancels out, so 1.6 and 9.9, I can say it is approximately 6. It is approximately 6, not exactly, little bit more than 6, because it is approximately 6. So Emax, maximum kinetic energy of the photoelectron Emax, h nu equal to 6, which is energy of the photoelectron minus what is the work function 4.2. 4.2, it is little bit more than 6. So if I just subtract it, it will become 8, 1.8. So it is very close to 2. So option D is the correct answer, because 6 is little bit, it is little bit more than 6. Okay, so 6.2 minus 4.2, it is approximately 1.9. So it is very close to 2. So we here have to find out what is very close to. So option D is the correct answer. Thank you all of you.